So thanks to anyone who's joined out there. The session is being recorded, so it will be available as well after the fact. We wanted to host this because there's so much noise in the market around AI, so many claims being made, and frankly, we feel for organizations having to wade through all the information and at least try to make informed choices. But the reality is it's very difficult to make wise, informed choices without having some basis of understanding. Not too much in the technical weeds, but just to be able to ask the right questions and discern the right solution or technology for you. So that was the impetus for this. And with that, I'll hand it over to Carter Maslin, our CEO and co-founder, who can shed some light and lead us through this. And there'll be a little bit of time at the end for any questions.
Excellent. Thanks, Melanie. Welcome, everybody. I figure we just have a few goals coming out of this. One is to have everybody understand what AI is at a fundamental level, just so that you have a framework for interpreting people's claims. And then how AI enables proactive security, which is just a discussion of the probabilities and approach that it takes to filter out the noise. And then how AI fits into a layered defense. So you've got a variety of different techniques to try to secure your facility, and we'll go over how AI is part of those layers. And then the most important thing is for everybody to walk away with the questions that you can ask vendors, just to vet claims and determine whether they match the needs that you have for your particular deployment. So that's what we're hoping to accomplish in this webinar. And we'll just dive in with a brief overview of what AI is, because there's a lot of different interpretations of AI, where some people feel like it's a definitive answer to some question as a checkbox feature, like, is there a human here or not? Or is there a vehicle here or not? And really at the core, AI is just a probability machine. So it's just guessing. And then it learns from its correct guesses and its incorrect guesses. So this is an illustration of a guess on recognizing the letter 5, the number 5 or 0 or 4. And this would be, as an example, you're doing license plate recognition, and there's some probability that it'll see an I as a T, or an I as an I, or an I maybe even as an L. And usually a great model is going to learn over time to get better and better answers, but there's always a trade-off between absolute precision, meaning no false positives, and absolute best recall, meaning no false negatives. And what AI does is it basically, it first came onto the scene when you may have seen deep learning for detecting cats on the internet. That was kind of the precipitation of all the research in deep learning and AI. And when there's a lot of different flavors of AI, there's AI that is looking at patterns over time. There's AI that's classifying images. There's AI that is just weeding out noise. So there is no one type of AI. There's a variety of techniques, but at their core, you can just think of them as nothing other than a probability machine that just learns how to guess better and better. And what it means for the security industry is that you've got a tool now for the first time to be able to pragmatically provide proactive threat mitigation, instead of just having evidence after the fact where something bad happens and your team is on point for determining what happened. You've got the help of machines to weed through hours and hours of information from door access controls and other sensor readers, point of sale systems, video systems, and make sense of it to the point where it's feasible to respond in real time. And it's not just about that proactive stance, but it's also just having a better return on the resources that you do deploy. So instead of dismissing thousands and thousands of door held open alarms, it'd be nice to only intervene in the ones where it's not people just streaming out of the building to go to lunch, and instead the ones where somebody is actually coming inside the building. So just looking at the manpower ROI, it's huge, because you can deploy people on things that matter. And everybody wants to be working on things that actually make a difference on the security posture of the company. One thing that's AI is not often associated with is lower cost, but it's actually a huge driver of lower costs. not just in the infrastructure costs of having awareness of what's happening in the video, so you can change how much storage you need and how much bandwidth you need and who sees which events, but also all of the costs in decreasing false alarms, which are often decreased by over 93% compared to what people are having to triage today. So a big cost factor, often enabling people to cover 50 times more locations with the same staff. And then on the efficiency front, instead of having a bank of live monitors where you randomly may catch something, you can have machines do the work to say, hey, you should take a look at this and keep track at what has been examined and what the latency is between the time of the event and how quickly it was triaged. So a lot of good things in pushing just a better security system with AI helping to weed out the noise. So these are the questions that are, I think, most central in evaluating a vendor's claim of AI for anything. In Camio's case, we provide things like mask detection, automatic tailgating detection, basic people and vehicle dwell times and things like that. So anytime someone says that they support a feature, it's important to know that it's not a checkbox. It's not like you say, I support face detection or I support mask detection. You really have to ask, what's the precision and recall of that particular feature? Because you in your real life environment want to know what are the false positive rates and false negative rates to know if it's practical for your solution and your setting and cameras. The second question is, what's the latency versus quality versus cost trade-off of this? Because you can equip a self-driving car with $50,000 worth of equipment and do a pretty good job. But that's a lot of expense for that level of precision. And everybody's got budget constraints, and there's often very pragmatic trade-offs you can make that still give you all the value of a great filter without just the brute force computation costs that you might otherwise incur without asking about, hey, if I only need a daily report of how many people have entered the building, how much does that save me versus a real-time report? But if I want real time on tailgating detection, does that impact my ability to do something like mask detection? And what are those trade-offs? So just asking about performance, because oftentimes applications don't have to be real time. And then the third is, what's the cash outlay and total cost of ownership? So even if something has got a great ROI, there's still often a challenge if that ROI only comes after you invest a huge amount of cash or significant amount of cash. So knowing what it takes to deploy the technology, do you need new machines? Do you need new cameras? Do you need things like that? Or can it run as an overlay on your existing equipment? Those kinds of cost discussions are important. And then finally, and probably most important, is just show me real life examples on my video or my access control system, because we'll see later in this that a lot of the details really matter in terms of the performance that you get around the frame rates and lighting and position of cameras, and just the comparison with real life usage versus kind of academic benchmarks. So first, I thought we would just define the terms that we're saying is the most important question to ask first, which is, what is the precision and recall? So this is a visual for trying to describe the calculation of precision and recall, which roughly correlates to false positive and false negatives. But you can see that precision is basically your true positives over all of your true positives and false positives. And that's basically saying, how accurate is it? So in this case, a true positive is when there's a group of people in the back alley at an unusual hour on the left here. Whereas a false positive is this blowing piece of plastic bag that is not warranting a guard's attention. And then on recall, you're trying to ask, how many of the true positives did you find out of all of the false negatives and true positives? And that's like differentiating, like, how well did you do finding this gang of people in the back alley compared to just a false negative where you missed a passing person. And so this is a visual on just doing that basic calculation, but the main point is that you're trying to get an assessment of how it's going to perform in real life. And when we were talking about the trade-offs between that, how it's not a binary answer of like, yes, there's a person, or no, there's a person. This is the kind of trade-off that AI often presents when you're applying something. So this is called a precision recall curve, where it's saying if you want 100% precision, like every time it's accurate, it's going to be at the cost of missing a lot of events. So when you see a demo from a vendor that says, watch, I'm going to do face recognition as Melanie opens the door, we get Melanie. And that may only be a population of 4 people in a test, and has nothing to do with all the, if you deployed it with 1,000 people or 2,000 people in a company, you'll have very different results. So you can always pick what your trade-off is. So in security, we have a unique perspective on that trade-off, because if you just go to an industry standard benchmark for AI, they're really trying to pick the optimal point between your precision and recall. They're trying to say that this is the best performing model, when really in the security industry, if you're doing an investigation trying to find a recreational vehicle that blew up outside of Nashville or something, you want to see everything that may remotely look like a recreational vehicle, not just the exact recreational vehicle, because of the fact that you don't want to have to redo your investigation if you missed something. And so security has a natural bias towards wanting to be inclusive of false positives, because the pain of a false negative is way bigger than the false positives. And so that's where this is illustrating that on the curve, you may, for your security deployment, pick something different than somebody might pick on a medical AI app or something, because you really don't want to have any false negatives. The other part of the trade-offs is latency, where if you get clear on your business objectives about how quickly you need to know something, you can save a lot of money. So this is just a comparison of like knowing an answer in 1 second and saying that versus saying it's okay to know in 2 minutes. It could be a huge savings, because if you give computers more time to do their AI inference, you can save money, because you don't have to have this peak provisioning to have some very low latency response to say, I've got to know in 1 second immediately. That takes a lot more compute power when you're processing thousands of video streams, for example, than it would if you said, as long as you tell me within 2 minutes, you can spread out the work. And then, in a non-busy scene, that saves a ton of money. So this is mainly just a point to ask about, or it's not even ask about, it's more think about your own business objectives and what the true latency is needed to accomplish what you're trying to achieve with the AI. Finally, in evaluating solutions, just have the perspective that there are going to be radical advances over the next couple of years. This is courtesy of the Embedded Vision Alliance, where they took a look at what the developments are in processors, algorithms, and frameworks and tools, and just took the midpoint in the multiplier that is expected in the next 2 years. And so if you just say, if it's 157 times more powerful processors with 21 times more powerful algorithms and 8 times more powerful tools, that combination means that we're going to be 26,000 times more powerful, not necessarily more accurate, but just have more compute power in the next 2 years. So if you're picking an AI solution, just ask about the longevity of it. If you have new needs and you need to deploy quickly, what does that take? Are you bound to one particular chipset, or can you launch new capabilities regardless of what chipsets you have out there? So this is more just asking about the flexibility to augment the system as you come up with new needs without necessarily replacing all equipment. The other thing in terms of planning your eval is that the demos are often misleading, because even the industry standard benchmarks, like from NIST benchmarks, that will basically compare people's accuracy on something like face recognition, they'll show results like this saying, we did a search for George Bush Jr. and look how well we found George Bush Jr. And the issue is that not only are these kind of portrait style photos where you've got a significant number of pixels on the face compared to like general video surveillance. But it's also, there's a variety of other conditions. So you look at the demo like this, and then you deploy it in real life, and it looks more like this, where you've got, blurry, low exposure frame rates at nighttime, and you've got the backs of people's heads with hats and stuff. So the main point around this is that getting it into your facility and giving it a try on real life data is a key benchmarking compared to just an abstract benchmarking from kind of a lab environment. And with so many different vendors and choices, this is our assessment. This is from our point of view. Part of the reason that Camio focuses on real-time video search is that we looked at the problem differently, saying, people in the security industry, they want to protect people and property and make their businesses run well. Their job is to do that protection. Their job isn't to just record video or just to lock doors or things. And so we were looking at it with a different question, saying, what's the way that we could have computers help protect a place with real-time alerts and data that would give insights into the threats that warrant attention? And so, there's relative strengths of having AI on the camera or on a VMS or in a VSaaS service. And what we really looked at is like, forget about the topology of your solution in terms of what goes where. Just think of the problem. You have a question and you want an answer. And then if you want to be alerted when that same thing happens in real life, like I want to know when people are in a garage at midnight solo, between midnight and 5 a.m., let's say, how do I just get a computer to tell me that? And that's where focusing on just the outcome of time to result on the things that warrant human attention is the focus of our real-time video search. And the benefit of AI, even with its mistakes, is that this has always amazed me about probabilities, but it's kind of magic when you layer independent systems together, each of which are flawed. They end up producing amazingly good reliability. So from a statistics perspective, if you only have 85% reliable access control, let's say that 15% of the people are piggybacking or tailgating, or there's some other door ajar event that lets them in, and you have 15% of those people coming in. But then if you combine that with 95% reliable human detection on your video system as another layer in your defense in detecting who's coming into the building, along with, and this is just estimate, 20% reliable on-premise guard, where he or she may be on a phone call or look away and they may miss stuff. So they may only be 1 out of 5 cases detecting things. The amazing thing is if each of those 3 layers are operating independently with their flaws, you still get 99% reliability if they're layered together. And that's the kind of benefits that have driven people that are using AI to get these kinds of benefits, where there was one company where they were just so galvanized by stolen laptops that were reported to them after the fact. They were saying, how do I not have that ever happen again? We want to be proactively notified if there's suspicious activities, that we can intervene while it's happening. And this is a quote where he said, it's about cost efficiency. We don't have people watching the video. The cameras do the work and notify us when we need to look. So this is where AI and machine learning provide that automated assist to just take the workload out of reviewing thousands and thousands of events all the time to present the ones that warrant your attention. But even on the infrastructure side, AI can have a big role. There's another university deployment where their director said, we didn't want to have to do this again in 4 years, meaning get us onto infrastructure that's going to continually improve. And that's part of the AI questions that we were talking about around what does it take for me to deploy a new model? When the pandemic started 2 years ago, Camio was the first to launch social distancing and mask detection. And we did that within 3 weeks of the start of the pandemic. And that kind of speed of response in deploying a new model is kind of a litmus test for what kind of infrastructure you have to be able to extend with new capabilities and new models. The same thing was in the deployment of these remote mining facilities where new AI models were deployed within 45 minutes, just using their existing virtual machines. So that ability to extend quickly is key. But just to wrap up, what is like a great recipe to work backwards from the business problem is proof of value, POV. So because of the fact that AI has so many variables, excuse me, in terms of price, performance, accuracy, latency, there's all these different kinds of considerations. The most effective way to simplify that is to just work backwards from the business objective, because a lot of times AI teams can help reach your business objective by just having intuitions about the best trade-offs to make. So this template is one that we highly recommend. You just start with, who is this solution for? What are their goals and tasks that they're trying to accomplish? And then why is it needed? So even if you know who has the goals, why do they need this particular solution? What are the problems that they're solving? And then clarify exactly what it is. So what are they expecting from the system? Are they expecting to get, for example, tailgating alerts with a false positive rate that's suited to their staffing level? So they may know, I can deal with about 60 false positives a day. And you want to get specific about that on what it is. It's like, this solution is going to give us tailgating alerts with a false positive rate that will produce no more than N number of events per day. That kind of precision, detail. And then finally, why it's needed. And this isn't complicated. It's more just, what is the new capability or cost reduction or efficiency gain that is going to give you the justification to roll this out? And that could be as simple as something like, hey, we have a ton of important contracts that require SOC 2 certification, which requires that we know who's in the building. So we have, we're launching this AI feature to do nothing other than reduce our rate of unauthorized entries by 10% quarter over quarter. And this is going to give us the feedback loop that will help us reduce that rate of unauthorized people. That's an example. And then the evaluation criteria, where you get specific around what does it take in terms of performance to justify the rollout, in terms of the precision, the quality of the AI, the reliability, the usability, supportability, all those factors. So this is often just a simple one-pager, but it's a great way to galvanize the whole team to get clear on, here's the outcome we really want to achieve. And then you can ask these key questions, which will wrap up with these key takeaway questions that are so central to evaluating the AI vendor claims. Ask about precision and recall for every AI feature. Understand what trade-offs you can make in latency versus quality and cost as part of your project rollout, because that'll be key for your pricing and budgeting. You could have a fantastic system like the self-driving car that's 120 grand per car, but it's impractical. You'd have to build the whole data center to just roll it out to your organization. Then be clear about the costs in terms of new hardware deployment and training stuff. But then most important is that fourth one, get real life examples for accurate assessments, where you can, and Camio actually provides tools to help with this, where you can run video for a day, export your results, and then look at the precision and recall in comparison to an existing video system. And so that kind of simple way to take just 100 samples and get a really good measure is really empowering for people that are evaluating the technology. Because one other statistics thing that I think is a fun nugget is that if you take 100 random samples that are truly random and you rate 100 of them as, false positive, true positive, false negative, true negative, just that rating, the resulting assessment is going to be accurate within 4% plus or minus. So with a very little amount of work, just a rating of 100 random samples, you can have a pretty accurate assessment of how it's going to perform in real life. So I hope this gave some framework to do a good kind of set of questions as you're evaluating AI. And we'd certainly welcome, you can contact us at info@camio.com if there's any other information that we can provide. But appreciate your learning more about AI and giving a good framework to your teams for evaluating the selection and choices that you have.